experiment 1 is about recrystallization of benzoic acid. The objectives of the experiment are to choose a single solvent to crystallize benzoic acid and to purify impure benzoic acid by recrystallization technique. So the pre-lab assignment, I already mentioned that you have to do it in your notebook. And then the procedure of the actual experiment actually in the next page. So I'm going to do first part A, which is choosing the right solvent for recrystallization or crystallization of benzoic acid. So now I already have the setup, and also now I have, so I'm going to show you that I have here. Okay, so I have the sample, which is pure benzoic acid. So, pure benzoic acid. And then I already have the spatula. And then I have a thermometer. I also have the solvents, water, 95% ethanol, petroleum ether, and acetone. So basically that's just water. And then this is ethanol. So this is 95% ethanol. That means 95% ethanol and 5% water. And then I have petroleum ether, also referred to as ligroin, but mainly this is a mixture of hexanes. And then I have the acetone reagent. Okay. And then I already have the tubes in here. So I labeled as water, ethanol, petroleum ether, and acetone. And I have the tubes also. Water, I labeled as W, E for ethanol, P, petroleum ether, and then acetone. So, and then I also have the ice water bath, and I also have the water bath being heated to about 70 degrees. So now I'm going to use for the first part, which is part A, pure benzoic acid, to determine the solvent that we're going to be using out of these four to crystallize benzoic acid. So we're just choosing one single solvent to crystallize an impure benzoic acid for part B. So the results from part A, we're going to use this for part B. Now I'm going to scoop a little bit of the sample. So actually I used the spatula, the micro spatula, and approximately about that much of the sample. So this amount, it's about this amount, okay, at the tip of the spatula, and I put it in the tube. So I already put approximately the same amount in water, the water tube, W tube, okay, and then I also have it in the E tube, so I have 4 tubes. I put the sample, okay, approximately the same amount of the solid, and then I also have the A, so I have 4 tubes. So this would be the water, ethanol, petroleum ether, and acetone. So I labeled that as W, E, and then B, and then A. Okay? So now I'm going to put first 10 drops of each of the solvent. So water, RO water, ethanol, petroleum ether, and acetone. So about 10 drops. We start with 10 drops. Okay? So right? I also put a boiling stick, so this is just a stick, and I'm going to crush. So I have a boiling stick, and I'm going to crush the solid at the bottom and try to dissolve it, because the crystals are big, and I try to crush it to dissolve. Okay, so right now this is room temperature. Okay, that's water. And then now I'm going to do ethanol. Okay, so I put water on the side, and then ethanol. Again, this is 95% ethanol. So again, everything is gonna be 10 drops first. Okay, so take note that some of the solvents are volatile. So we're gonna be using a lot of organic solvents. And when you, at the beginning, because sometimes it's volatile, it would squirt out. So the best is you pipette up and down to saturate the bulb with the vapor, and you can hold it and it doesn't squirt out. Okay, so I'm gonna put 10 drops on the E tube. Right, that's E, and then I'm going to put again a boiling stick and try to crush it. Okay, and then okay, so I'll set that aside, and then I'm going to now put petroleum ether. Okay, so again 10 drops, and again you pipe it up and down to saturate the bulb so it doesn't squirt out, because these are volatile solvents. This is not like water. So P for petroleum ether. So again, this is, we'll just say this is hexane, because actually this is a mixture of isomeric hexanes. Okay, so again another boiling stick. And now the last one is acetone. So A is for acetone. So again, boiling stick, and I try to crush it. Okay, so I'm gonna go back to water, and we'll try to observe. So in your report form, you are filling up, or in your notebook first, so you're gonna be filling up this table. So I have here the first row is gonna be RT, that's room temperature, water, 95% ethanol, petroleum ether, and then acetone. You're gonna fill up the first row. RT is just room temperature, room temperature, room temperature, room temperature. Okay, so let's go back and now look at what we have here. So I'm just gonna crush it and then try to see. Okay. All right. So petroleum ether. It's a little bit turbid for the petroleum ether, and then acetone. Okay. So I'm gonna push that big chunk at the bottom. Okay, so now let's see. So let's go back to water. All right. So I'm crushing it, and you probably can see still the crystals at the bottom. Okay, you can see it looks like there are less crystals, okay, than before. And I'm still crushing it, okay. And then the ethanol, you can see less, okay. So in fact, I need to add a little bit more of ethanol because the ethanol is more volatile than your water. So I'm gonna add more so that I can make a better comparison if the solvents have the same level, okay. So this is water. I'm just gonna add a little bit more to make the level even. So even, okay. So again, remember that this is a qualitative determination of the amount of solvent and also the solvent that we want to crystallize a benzoic acid, the impure benzoic acid. Okay, so that's about kind of the same. So now, okay, I might have added a bit more of the ethanol, but now I'm gonna make it even so that I have a better idea. So I think I added just maybe 2 drops of the water, so I'm just gonna add 2 more drops of the water, maybe 3. Okay, so this is ethanol. E is ethanol. E is ethanol on the right, and then W is water. So as you can see, if I have the card in here, the ethanol actually don't see anymore, okay? However, the water still has. So I have less of the solid for my water at room temperature. However, the ethanol is completely dissolved. So the sample is completely dissolved in ethanol, 95% ethanol at room temperature. So now let's do the petroleum ether and then acetone. So again, the petroleum ether is volatile. So organic solvents typically are volatile, more volatile than your water. So I'm going to make it the same amount as the water, okay, so I can make a comparison. So on my left is water, W, and then petroleum ether on my right, P, okay. Okay. So if I compare the water and then petroleum ether sample, you can see that it's actually, it gets turbid if I shake it or if I mix it, if I stir it, okay. So the one on the right, the one I'm stirring right now, is petroleum ether, and it's slightly turbid. So that means that it has, the benzoic acid has solubility in the petroleum ether, okay. So you can see it's slightly turbid. It has some solubility. This water is actually not very soluble, the sample or the solute. So you can see that there's still a lot of solid at the bottom. Okay, this one you can see that it's starting to be turbid, the one on my right, and you can see some cloudiness. Okay, all right, so that's petroleum ether, the one on the right, which is this sample. So then we have acetone. So acetone, actually, even though the height of the solvent is less, I don't really have to add it just to save reagent. So acetone is A. Acetone is A on the right. Has actually less solvent. It evaporated some of it, but I don't see any particles at the bottom, this sample here. Okay, so even though I'm not going to add anymore, that means that this is soluble at room temperature. I can actually push this now. It's okay, done. So I can push. There's a little bit of sample on the side. I can push it, but it's soluble, even though I'm not. So this sample here, the one I'm stirring, is acetone. That's A sample is acetone. The sample, or the solute benzoic acid, is soluble in acetone. Okay, this is still water. All right, so this is water over here. Okay, you can still see the particles swimming. All right, so now let's review. So let's review. This is water, ethanol, petroleum ether, and acetone. So ethanol and acetone sample, the solute is very soluble at room temperature. However, the behavior of the solute in water as well as in petroleum ether are similar. Okay? So now the next step is to heat it up. So we're going to heat it up at 70 degrees C. So I already have a water bath in here. So I have the thermometer. I'm going to measure the temperature right now. So I want it to be approximately 70 or less. Okay, so it's about 66. So temperature right now is approximately, I think, about 67 or so. Okay. So I'm gonna turn it. So it's about, my setting is, I think, about between 50 and 60, something like that. So it's about 67 right now. So now I'm ready to put the tubes, the 2 tubes containing the water solvent and then as well as the petroleum ether into the water bath. Okay, so this is, we're gonna put first water. So I'm gonna stick it here. Okay, and then we observe. I don't want it to like boil over, so I'm gonna watch it. Okay, and then petroleum ether I'm also going to stick into the water bath. All right, so I don't want it to be boiling over, and actually this one is boiling already, so I'm gonna remove it and then see if it actually, I was able to dissolve it. All right. So I might have to add more solvent. So I'm gonna put the ethanol and acetone to the back because I'm done with it. I don't really have any reason for that to be heated up because it's already dissolved at room temperature. So however, these 2 samples I need to now see what I can do, right? So because it feels hot and I still have some sample or solute at the bottom, I'm going to add 10 more drops of the water as well as the petroleum ether. And then I can make a comparison, almost the same level of the solvents. Okay, so I'm gonna add water. So this is just water. I'm just gonna add 10 more drops. So total of 20 drops. Okay, and then again, mix it up. And then I try to crush the particles. So this is just water that I put. Okay, anyways, I'm gonna stick it back into the water bath. And now I'm going to do petroleum ether. So again, 10 drops, or I actually wanted to make sure that I have the same amount. So I'm just gonna do that. So I have, for me to make a comparison. So this is just petroleum ether. So again, look that if I take up, put up the pipette, it would drip. So the one technique is to saturate it by pipetting up and down with the plastic pipette several times, and then now if I can lift it, and then it doesn't squirt all over me. All right, so that's one way to do it. So 10 drops. Okay, so approximately the same volume. So approximately the same volume, and then I'm just gonna cap these. Okay, so all right, so I'm gonna crush again the water, the solute in the, or benzoic acid in the water, and then I'm gonna stick it again here, and then the same thing for the petroleum ether sample. Okay, so again, heat it up. So I'm getting some, it's getting clear, so I have to watch it so that it doesn't boil over my tube. So as you can see, it actually is starting to be clear in the petroleum ether solvent. All right, so it's soluble when I heated this up, and it gets clear. Okay, so that's my petroleum ether sample. Okay, so several times until I see that it's actually clear. All right. So I can add a little bit more, see if I can get that better. So basically for this one, it's still not dissolved, so I might have to add also, but let's try first petroleum ether because I'm getting some, it's getting clear. So I'm gonna add 5 drops. Okay, and do again. Okay. So the water the same, so I think I'm gonna add a total of, so I'm now adding 5 more, so it's gonna be 30 drops. Okay. So let's go back to water. I'm gonna take it out, and as you can see, it's also not yet dissolved. So I'm gonna add now 10 more drops, so I have the same amount as in the petroleum ether. Because I still have a lot of particles. So I probably have added a little bit more than I wanted, but it doesn't really matter right now because we're trying to see if I can get it to dissolve when I heated it up. So this one actually is, this is now the sample that I'm warming the petroleum ether. So as you can see, after I added 35 drops, I now see it's clear. Okay, so I was able to dissolve it. So this is the sample after I added 35 drops of the solvent, which is petroleum ether. Now it's not hot anymore. I'm gonna stick it into the hot, so it's not warm anymore. I'm gonna stick it to the ice water bath because I want to see if I can crystallize it out of the solution after I dissolve it. Okay. So now this water here sample is still, I'm still crushing it, and it's taking a while. Probably need to heat it some more, but I see less solute now. So now, actually, after I chilled the solute in I chilled in an ice water bath, you can see that I can crystallize out the benzoic acid. Is coming now out of solution. Okay, so you can see the crystals actually at the bottom over here. Okay, so it's white. So I get back the sample. So the benzoic acid is white. So let me show you how it looks like. So I showed you earlier, right? So it's actually, so this is white. Okay, but big chunks of crystals of benzoic acid. So that's the sample that I use, which is the pure benzoic acid. Okay. So this is now the water sample that I was heating. So it took me a while to get it to dissolve. I was crushing and at the same time heating it up. So I finally got it to dissolve after 35 drops of the water. And you can see that I don't have any more crystals at the bottom. So it's entirely dissolved. It's still a little bit warm. Okay. So when it gets to room temperature, I'm going to stick it again into the ice water bath. Okay. So I'm gonna let it sit for like a few minutes, and then I will stick it in the ice water bath. So when I have the water almost, it's still a little bit warm, but I think it's not as hot anymore when I touch it. So you can see that it actually starts to crystallize out. So I'm gonna stick it in ice water bath to get back my crystals. So just a few minutes, and so I get back all the crystals here. You can see. Okay, so let's review what we have right now. So we have W, water, ethanol, petroleum ether, and acetone. So remember that the ethanol and acetone solvent, when we use it, it's completely dissolved at room temperature. However, for the water and petroleum ether, it's a little bit soluble, but there were still a lot of solid at the bottom, a lot of solute at the bottom, and I ended up adding a total of 35 drops of the solvent for the water and then petroleum ether, and then I heated it up, and then I got it to dissolve. The water took a little bit longer to dissolve, but the petroleum ether, it was faster in terms of dissolving it in the solvent, and then when I chill in ice water for both, I got back the crystals. Basically, that's it for part A, and we're now going to do part B. So from this one, we decide which solvent we're going to use. So write down in your conclusion the reason why you will pick that solvent. So it's possible that for this part, you can actually, there's more than one answer, not just one solvent that you can use. There's going to be more than one answer to for the right solvent to crystallize impure benzoic acid. part B is now about recrystallization of impure benzoic acid. And I'm going to follow this procedure. I will first weigh an e-flask, and I will put the impure benzoic acid into the e-flask. So write down the weight that I'm going to use, so that for part B. So I put the e-flask inside the balance, and right now it's 0. And then I'm gonna put the sample, which is labeled as impure benzoic acid unknown A. So I'm gonna put about 0.400 grams of the impure benzoic acid inside the e-flask. So this is the sample of the impure benzoic acid. It looks like this. Okay, so I scoop about 0.400, but right now the weight, so write down the weight please of the impure benzoic acid that I put in the e-flask. So right now it's the weight is 0.418. So it doesn't have to be exactly 0.400, as long as we know the exact weight. The exact weight that we are using, it's now 0.418 grams. So you take it out, and this is the sample that we're going to be doing and using for part B. So now this is the impure benzoic acid. So I added the solvent that we determined from part A, and I added just 5 ml. So actually there's a slight pink coloration because we put an impurity, purposely put an impurity as an exercise in this experiment. So after I added 5 ml of the solvent that we chose from part A, I'm now heating up the sample. So I can see now that it's light pink in color, and I'm also going to stick a boiling stick so that I can control the heating so it doesn't like boil over. Okay. So I'm going to crush again the sample. Okay, so if it starts to kind of boil a little bit or heat up, and then I don't see the sample dissolving, I will add more solvent. So basically right now we want, so based on the ideal, based on the characteristics of ideal solvent to crystallize a solid, so we want the sample to dissolve when it's hot, and then when we cool it, we can get back the crystals after heating it and then cooling it from temperature and then chilling it in ice water. We should be able to get back the sample or the solid from the solution. So right now we are trying to dissolve the sample so that we can dissolve everything, including the impurity, into the solution. So I can see that I see some sweat going up, and I still see a lot of solid at the bottom. I'm going to add more solvent so that I can completely dissolve the sample. I'm heating the sample, so I added a total of 20 ml of the solvent, and it's hot, and I'm trying to crush the sample. I still have undissolved particles at the bottom, and I want it to be completely dissolved. So while I'm waiting for this to be completely dissolved, so again the color is because of the methyl orange, it's pink, and so while we're waiting for this to dissolve, I'm thinking ahead because I want now to set up the vacuum filtration. So I will weigh first a filter paper. So filter paper inside the balance, the weight is 0.212 grams. So write this down, please. 0.212 grams is the weight of the filter paper. So the solid completely dissolved. and it took me about 20 minutes to get it to dissolve. And I don't really want to boil it, so I just try to control the temperature, heat it, and then all the sample or the solid dissolve. And again, the color is still dark pink. So I'm gonna let it cool to room temperature, and I'm gonna chill it in ice water when it's almost at room temperature. Okay, so I'm done with the heater, and I turn it off the hot plate. So it's about 10 minutes since I took it out from the hot plate. So you can see, in fact, that there's it started to crystallize already, and big crystals. So you want the crystals to be big, large, so that when you filter it, you have less impurity that would adhere to the sample. So you want to get rid of the impurity. So if the crystals are big, the sample will be more pure because the impurity will not stick to your sample. So now it's almost room temperature. I'm gonna stick it to the ice water bath, and then leave it for about 5 minutes, and then we are ready to filter. This is the setup for vacuum filtration. So it's connected to the water aspirator, and then we have the filter flask, and we have the Buchner funnel. So the filter paper I weighed, I'm gonna put it inside, and then when we're ready, we are going to filter, apply the vacuum, and pour the solution in here. So the idea is for the filtrate or the solution to go through, and then the crystals to be in the filter paper. So now we're filtering. This is the vacuum filtration part of the experiment. There's a suction, and then the filter paper is inside. So you have to moisten this filter paper so that it's stuck to the bottom and there's no airspace. Otherwise, if there's an airspace and the filter paper is not flat to the bottom, it's going to, when you filter, the product or the solid might go through. So you want this to be, the filter paper to be stuck to the bottom, flat at the bottom. So this is now the sample. So this is cold to the touch. So I chilled it in ice water. So I'm now ready to filter. Okay, so I'm just gonna pour it in here. So the idea is for the crystals or the benzoic acid that were crystallized to be in the filter paper, and all the impurities go through, and then I should see this actually pink. So right now there really is nothing in here. So I'm gonna pour it. Alright, so pour it in here. Alright, so I can press it so that it goes through, and then basically the filtrate is now pink. Okay, so I was able to separate the methyl orange impurity in my samples. I can rinse it some more so I can collect as much as possible my solid, and then I'm gonna rinse that with the solvent that I use based on part A. So I got everything out, and I now have the solid in my filter paper, and then the filtrate is pink, and basically all the impurities should go through, and what is in here is just the pure benzoic acid. So we will test if it's actually pure using melting point determination, but we will weigh this first. I'm gonna dry this overnight or for a week, typically for a week, because the next lab period is a week. And then I'm just gonna detach from the vacuum. So I take it out slowly, and then I turn off this water aspirator, and we're done. So we're just going to discard this in the proper waste container, and then the sample is now here, so I can detach it, and this is now what it looks like. So I don't see any pink coloration in my sample right now, so we're gonna let it dry. It's a little bit shiny at this point, so when we dry it, we'll see how it looks like. This is now the sample a week after drying. So technically, you do this in the next lab period, which is going to be a week later. So you're going to be drying this the same thing. I dried it for a week, and then you see that the crystals are actually shiny and it's still stuck to the bottom. So I'm going to take out the filter paper with the sample, and then I'm gonna weigh the sample. So remember, we had the weight of the filter paper. Okay, so in the balance right now, I zeroed the weighing boat. So the weighing boat inside the balance, and it's 0 right now. I'm now taking the sample out so the filter paper lifts easily, and now I'm going to transfer it into the boat, and that basically is our sample. And I will try to, there's some particles inside, so I'm gonna scrape it out so that I can get the whole weight. Okay. So the particles, they're white, and it's, after recrystallizing it, it looks flaky, but it's shiny, as you can see. Okay, so this is now the sample, and now I am going to weigh the filter paper and then the crystals. Okay, so write down the weight. So it was 0. So that was the weight of the boat, that was actually 0. So right now the weight of the filter paper and the crystals is 0.369. So again, the weight is 0.369 grams. So again, that's the weight, total weight of the crystals and the filter paper. So you will now subtract the weight of the filter paper because we weighed it before we did vacuum filtration. This is the last part of the experiment, and I'm doing a melting point determination. So this is our sample, recrystallized benzoic acid, and this is going to be the impure unknown A benzoic acid. So I scoop a little bit of the sample into this small weighing boat, and then this is the sample, okay? And then I'm going to pack the capillary tube. So this is the melting point tube, capillary tube. It's actually it's a glass tubing, small glass tubing, and then this is closed end, this is the open end. Okay, so you are going to scoop a little bit of the sample, and then I'm going to drop it in this glass tubing so that I'm packing these at the closed end. So for example, if I'm using, so I'm going to use the impure benzoic acid, so I'm going to, so this is the open end here, and I'm going to crush it, okay, and then I'll try to scoop it. So I have some samples in here, okay, and then I will try to pack it on this end. Okay, so I will drop it several times in here onto the bench top until I pack it to about 2 to 3 millimeter. But I want both tubes, so I'm gonna have 2 tubes to be almost the same height so I can make a comparison. So I still have a little bit to go. Okay, so I'm gonna do it several times to pack. So this is the tube, and I have some crystals here on top, and I'm going to drop it on this glass tubing, open end, but the diameter is bigger than my capillary tube. So I'm going to drop it on top, okay, and then so that I'm packing the closed end. So I think I have enough already. So as you can see, I have now the sample at the closed end. Okay, so that should be enough. Okay, so I mark it with a black pen, and that was the unknown A. Okay, so the black pen, unknown A, I labeled. Okay, so that's our first sample. So I'm gonna do the same thing for our recrystallized benzoic acid. We're gonna do the melting point and compare the 2 samples. So I now have the 2 samples. The one on the left, actually I marked on top with a pen, black pen, and I have almost equal amount of the two samples. Remember, the one that I marked with a black pen is the unknown A impure sample. The one on the right is the pure sample. Now we're going to do melting point determination. This is the melt temp apparatus, or the melting point apparatus, and I'm going to turn it on. There's a rocker switch on the side, and since I know the melting point of pure benzoic acid, I will set it at that temperature, but slightly lower. So the temperature, or the melting point of benzoic acid, is 123, and then I'm gonna set it to about 121 or 122, because typically the ones that reported in the literature is slightly higher, but the actual temperature is slightly lower. So I'm just gonna set it to slightly lower temperature, and I plateau it at that temperature. So basically, what you do is I press the plateau. There's a plateau set in here, the middle button, and then I press it, and then I'm going to press it to 122. Okay, so that sets the peak of the heating block. Okay, if it doesn't melt at the temperature, I will increase it slightly, close to it, because sometimes if you set it too high, it might melt so fast. So I want to make sure that I'm not overheating. So now I'm going to put the sample. So there are two slots on the side, and I'm gonna put the one that is the unknown A. Okay, so there's a slot here. Okay, and then I'm going to put the recrystallized sample on the other one. Okay, at the lower one. So, all right, so I want to make sure that I can look at this eyepiece in here, and I can see the inside. Okay. Okay, so I'm gonna start. Okay, right now it's just room temperature, so I press start, and then it starts to heat up. Okay, so I'm gonna look at the eyepiece, but maybe the camera would be able to see it, but I doubt it. You can see maybe the inside. So I have the tubes actually inside. The top one is the one which is unknown A sample, impure one. The bottom one is going to be the pure sample. To melt the impure sample at about 113 to 120, and the sample, increase it to 124, and you can see that the top one became pink. So the sample already melted. Actually, the melting point was about 123 to 124, and then I'm going to take out the sample, because you can see that the top one became pink. So I'm going to pull it out. It will immediately become a solid, because the room temperature is lower temperature than the heating block, so it will immediately become a solid. So if I take out the top one, you can see that it's actually pink. All right, you can see the pink color in my lab coat. Okay, so it's starting to solidify again, but this one, yeah, it started to solidify too. Okay, so the unknown A, the one that I labeled with the black one, is actually became pink. All right, so I'm gonna turn this off, stop, turn off. So that's it for this experiment. All right, so I unplug it. Typically when you are doing or using this equipment, you have to put it back where you took it. It's typically on top of the bench, and make sure that everything is off. So to discard this, I'm still showing you guys even though we're not doing this face to face. So this one is the glass tubing, it goes to the glass waste. Okay?